Nobody really expected this. The James Webb Space Telescope has discovered 15 strange galaxies that existed before the Big Bang. With this discovery, we are now at the beginning of a completely new era. Our cosmology and science as a whole will experience an unprecedented upheaval, and our entire view of creation and its causes may change completely. What if the Big Bang never happened? Are we possibly looking into a parallel universe? And why has our science failed? Nobel laureate Dr. John C. Mather, the lead project scientist for the Webb telescope, put it in a nutshell at a press conference on current events. He said, "Of James Webb's discoveries, we're looking further back in time than ever before, and we're really excited about this picture. We've been working on the question of how the galaxies formed, and I thought we would see that in the images. But we've seen galaxies that have been a big surprise. They are bigger, brighter, hotter than we expected." Some people said then, our whole story of the expanding universe could be wrong. I think it's more likely that our story of how stars formed is wrong. The James Webb Space Telescope discovered at least 15 galaxies that are so old, so massive, and so bright that they shouldn't even exist. It may also have been 6 black holes, which are also so old that their beginnings must go back beyond the time of the Big Bang. In James Webb's pictures, a series of objects appear that are so strange and so old that they confuse scientists. Most of these are too complexly organized and structured to have been baby galaxies 300 or 400 million years after the Big Bang. Scientists expected some star clusters to harbor the legendary population 3 stars. These first stars are said to have been huge and luminous but only had a short lifespan. The shocks continue, and James Webb discovered another galaxy. It turned out to be so low in luminosity that it also does not fit into the picture of star clusters with bright supergiants. Another discovery could be 6 black holes that were already so gigantic 500 million years after the Big Bang that we have to ask ourselves where all the matter came from that made them grow to these sizes. Previous cosmological models tell us that it takes billions of years for galaxies or black holes to take on the forms that James Webb is now showing us at the beginning of time. How far do telescopes see, James? How far do telescopes see? Webb has an approximate range of 13.5 billion years. The telescope does not significantly surpass its predecessor Hubble, but Webb looks more clearly into space and notices more details. The oldest galaxy discovered by Hubble was GNZ 11, which existed around 13.4 billion years ago. James Webb, on the other hand, has now discovered dozens of galaxies in the depths of the cosmos, some of which are said to have incredible redshifts of up to Z20. 15 of these galaxies have now been confirmed, and scientists must now explain their existence. These galaxies become visible to us through the light they once emitted. Telescopes capture the light and act as real-time machines. We look into the past as if through a tube and can gain vivid impressions of how the universe looked at the beginning of time through light signals that are billions of years old. In addition to light, there is another major indicator in the universe, the cosmic background radiation. The cosmic background radiation, or cosmic microwave background radiation, is a remnant from the early days of the universe. As an almost uniform radiation field that permeates the entire universe, it still carries messages from distant events through space. It was discovered rather by chance in 1965 by the American physicists Arno Penzias and Robert Wilson when they noticed a strange noise in space. It is perceived by gigantic radio telescopes as a weak microwave signal coming from all directions in the sky. Their discovery confirmed, among other things, the Big Bang theory and the assumption that the universe is expanding. The background radiation is a reflection of the state that existed around 380,000 years after the Big Bang, when the universe very slowly began to release photons and produce light. So even with the background radiation, we cannot see all the way back to the Big Bang. However, cosmic background radiation helps us to reconstruct the composition, density, and temperature of the early universe. Scientists can read thousands of details from cosmic structures and details from tiny fluctuations in their uniform distribution. These observations have so far helped to explain common cosmological models, but now we have to question these findings too. At the same time as researchers are now on the trail of the latest mysteries of light, such as shining galaxies or brightly glowing dust disks from black holes, radio astronomers continue to listen into space and try to use the cosmic background radiation to listen even further back in time and find clues as to what really happened back. Unusually old GNZ 11. What many people are not aware of is that unusually old galaxies have not only been discovered since the new James Webb era. Back in 2016, a research team led by Pascal O.S. and G. Illingworth succeeded in identifying a very old galaxy using the Hubble Space Telescope, with a redshift of Z equal to 11.09. The light from GNZ 11 had been traveling for more than 13 billion years before it hit Hubble's observation mirror. This redshift places GNZ 11 as the most distant known galaxy. GNZ 11 caught the attention of scientists not only because of its enormous distance, but also because of its unusual physical properties. Despite its young age by cosmic standards, GNZ 11 is surprisingly bright and large. At the time we see the galaxy, only 400 million years had passed since the Big Bang. This meant that GNZ 11 must be one of the oldest galaxies from our point of view, but it was young at the time and surprisingly well developed. Scientists estimate that it took billions of years to form complex galaxies like this one, with an estimated mass of about 1 billion solar masses and a star formation rate of about 20 solar masses per year. It also shows unexpectedly rapid evolution and activity. Observing and analyzing GNZ 11 in 2016 was a technological challenge. The light from this galaxy is not only extremely faint, but also so strongly shifted into the red that the capabilities of the Hubble Space Telescope were pushed to their limits. Of course, researchers were already wondering about this strange find in 2016, but back then GNZ 11 was just one galaxy among many and was considered an exotic. Now we know that thousands of highly organized and massive galaxies probably already existed in the young universe. Even older, AGSC 13. The James Webb Space Telescope is truly fooling researchers at the moment. One discovery after another is making the scientific community look old. All those who thought they knew what those first galaxies and stars looked like are now being shown something different by the universe. JADE's GSC-11 is a high redshift Lyman break galaxy that was discovered by the James Webb Space Telescope on September 29, 2022. This discovery was made as part of the JWST Advanced Deep Extragalactic Survey, or JADE's mission for short. JADE's GSC-11 has, as the name suggests, a redshift value of 13, which means that the galaxy existed around 13.4 billion years ago, and therefore only around 400 million years after the Big Bang. Only James Webb was able to capture the light of this extremely distant galaxy using his technique specially designed for observation in the infrared range. Redshift is a phenomenon in astronomy that is closely linked to the expansion of the universe. It occurs when the light from stars or galaxies is shifted towards longer red wavelengths. The reason for this is most likely the expansion of the universe, but it can also be caused by the movement of objects in a gravitational field or by the Doppler effect, in which the movement of the light source is relative to the observer. The effect was first observed in the early 20th century by astronomers such as Vesto Slipher and later Edwin Hubble. Hubble found that distant galaxies exhibit a redshift proportional to their distance from Earth. This observation gave us the Hubble law, which not only describes the age and direction of movement of galaxies but is also the basis for the expansion theory of the universe. Incredible, Sears 2112. Just when researchers thought it couldn't get any worse, another appeared. Sears 2112 topped off the confusion. Although this Bart's spiral galaxy is not quite as old as GNZ-11 or JADE's Z13, at only Z equal to 3, this galaxy is an almost exact twin of our Milky Way. Spiral galaxies normally take many billions of years to develop, but Sears 2112 can also have only been 2 billion years old when it emitted this light. The high redshift shows that Sears 212 originates from a time when the universe was already a little older, but it was still in its infancy. The stellar mass of Sears 2112 is estimated to be around 3.9 times 10 to the power of 9 solar masses. This also indicates that the galaxy was already in a relatively mature state when the universe was just 2 billion years old. This raises uncomfortable questions about how a galaxy could develop such mass and structure in such a short time after the Big Bang, considering that galaxies take billions of years to evolve. We are certainly not looking at galaxies that are just a few 100 million years or 2 billion years old. These galaxies must be older, which means that they must have existed before the Big Bang. Possible explanations occurred. What are the explanations for this? You probably already have a theory or two as to how the great age of these supposedly young galaxies can be explained. Let's take a look at the possible solutions. The universe is much older. After the shocking findings of the James Webb Telescope, we have to consider that the universe is much older. There is even a theory for this, which was developed by the Canadian-Indian researcher Rendra Gupta. He explains the theory of the expanding universe with light that tires on its way through space. If this assumption is correct, all our previous distance measurements could be wrong. The universe has no beginning. So far, there is no real proof of the Big Bang, only the expansion and the cosmic background radiation point to it. But these observations could be wrong. In quantum mechanics, we find several indications that the universe is infinite in time and space. There was another beginning. Scientists suspect that in addition to the idea of the expansion of the universe from a single point, there are at least a dozen other explanations as to how our cosmos came into being. One of these is that the universe is fed by several sources, and that these need not all have come into being at the same time. Press the subscribe button because there are many more highlights to come.